In this video, we will continue with parametric differentiation. You will find this on page 507 in the Namibian AS-Level Mathematics textbook, y equals mx+c to success. Let's look at another example. The diagram shows the curve with parametric equations x equals 3 cos t and y is equal to 2 cos t minus 1 over 6 pi for t is bigger than 0 and smaller than 2 pi. Show that dy over dx, so after I differentiate it, I will get this. Stop there. Okay, first write your first equation down. Now, just remember we are going to use the chain rule. So it's almost like you make this u and then you end up with 2, I just showed you there, the outside and then the inside. But it's basically 2 cos u, okay? And then if you differentiate this, then this is going to become negative. Okay, so this is going, and u, let me just write u, it's t minus 1 over 6 pi. So if I differentiate this, it's becoming negative 2 sin u. So there I rewrite u. And if I differentiate this, because it's only that t is only 1, and there I differentiate it with the chain rule. This one, if I differentiate dx over dt, then it's negative 3 sin t. Okay, I put the negative on top there, and then I put it at the bottom again. So I preferred, don't put it on top, keep it to the bottom. Okay, you don't have to put it there on top, just blank it out. Okay, so if I multiply, I'm basically just taking this. Okay, don't forget, before you multiply, that you must swap this one around. Where is the one that I swap around? dt, there is the one I swapped around. So now I multiply. So if I'm taking this one, okay, let me rather get another color. If I take this one, this is the one there, and I multiply with this one, can you see the negative is now at the bottom, and that's why I left it. I'm going to write in the reprint, I will write it at the bottom. And then I'm getting this. And then don't forget your chapter 10, trigonometry, further trigonometry. This is again compound angle, so I can go and I can break it up. There I showed you. So it's sin t cos 1 over 6 and cos t sin 1 over 6. Okay, so then I can basically just go and I multiply this 2 in and I break it up into the separate denominators. And now don't forget, as soon as you see 1 over 6 pi, you know it's your special angles. So just take note, this one cancel out, and there's my, and cos is adjacent over hypotenuse, and there it is. Okay, now this one, it don't cancel out, but I can make it cot, and then don't forget your sin is opposite over adjacent, so it's 1 over 2. And if I simplify this, basically the 2's cancel there, and it's only square root 3 over 3. There's my cot, the 2's cancel over 3. And I can take 1 over 3 out as a common factor and then as they show there. So it's quite simplifying before you come to this and quite challenging example. Okay, so let's look at number B, where the curve cuts the positive y-axis. So find the equation of the tan to the curve at the point where the curve crosses the positive y-axis. So it's there, do you see? And what is the value of x there? It's 0. Okay, so when x is 0, I go to this equation, do you see there? And I put a 0 there. And if I go further, I'm going to say, if I divide by 3, it's just going to be like this. Okay, and so it's actually cos t equals 0. Now, if you think of the graph of cos, let's just think of the graph of cos. This is the graph of cos. Okay. Now, there in the middle, it's pi. And then there, where it cut, it's pi over 2. So where is the first, where you get it's pi over 2, and that's where t is pi over 2. So the y-intercept, when t is pi over 2, because I work it out there. So now I go to this equation. Okay, and in the place of t, I put pi over 2. Okay, now I can actually use a calculator. Just make sure it's on radians. So if you really press this, you're going to say 2 cos, okay, or let me just see if we can simplify that. If we say shift pi divide 2 equals minus shift pi divide 6 equals. Okay, and then if we press cos equals. Oh, the problem is I'm not on radians. Okay, let's just go to radians. Mode, and 2. Okay, so let's press it again. So it's 2 multiplied cos, bracket, and then you can just say shift pi divide 2 minus shift pi divide 6, close the bracket, equals. And I'm just getting that one. Okay, so what is my point there now? So at 0 and 1, so that point is basically then 1. So at 0 and 1, the gradient of the curve, now I'm going to put that there is my gradient. Remember, this is my gradient. Okay, let's keep it to green. There is my gradient. So I take that formula and I'm just basically putting the pi over 2 in there. Okay, so if I do that, if I multiply, I get pi over 3. But if you press, and you can even, it's a bit difficult to press, but if you go back to chapter 10, to your summaries, you would have seen, the Cot, how is the Cot graph looking? You must know the basic ones. And the Cot one, can I just show you quickly? The Cot one is almost like the opposite of the tan. So the Cot one will go like this. Not such a good. Okay. And there's pi. And then there will be pi over 2, exactly there in the middle. And what will that be? 0. So cot pi over 2 will be equal to 0. And you can see, go to chapter 10, go to the summary, and you will see that graph. Okay, so that's 0, and that's why I end up with that. So at the gradient of the curve is that. And now I'm going to find tangent. So how do I find the tangent? I have my point 0 and 1. There's my point 0 and 1. And there is that. So then it's going to be y minus 1 equals, I put in this x minus 0. And then I'm just basically going to do, just take that 1 over and get, and there is the equation of my tangent. I will advise you to go a second time through this question, because especially the B part, it's a bit tricky, just concentrating on all your curves and find the values and substituting everything incorrectly. So go a second time through that example. I want you to stop the video and I want you to do the following. I want you to do number 3. I just decide, I think we have enough of cos and sin. And let's just go to ln a little bit again. So number 3. And again, you can continue the video as soon as you are finished. Okay, it don't seem to me I wrote there, try now. So this is try now. And we can just check. 39. Try now 39. Okay, let's start. So my two equations is x is equal to ln t plus 1 and y is equal to e 2t plus 2t. Okay, so if I differentiate this, so find the expression for this. So let's start. dx over dt. Now it's also the chain rule. So okay, let's just get another color. That is actually u. So it's 1 over u, and u is just 1. Okay, so if you differentiate or the outside, inside, but you're just going to get 1 over t plus 1. And if I swap it around, it's t plus 1. And then this one, dy over dt, is equal to 2e 2t plus 2. Okay. So if I multiply this now, dy over dx, I'm going to get this t plus 1. I can multiply it in, but I'm going to first leave it like that. It's not really going to make such a difference. Okay, there's my differentiated formula, and they didn't show to come to something, so that will be my number A. And now I will start with number B. Find the equation of the normal now to the curve at the point where t is 0. Okay. So where t is 0, I'm first going to find that point. Okay, so I have my two equations. So if I take my first equation of x equals ln t plus 1 and I put 0, then it's ln 0 plus 1, and it's actually just ln 1, so it's 0. Okay, and if I go to my y, what is my y? It's e 2t plus 2t. And again I go with my t equals 0, so it's e 2 0 plus 2 0, and that will give me e to the power 0 plus 0, and that will just give me 1. Okay, so basically my point, so therefore my point will be 0 and 1. Okay, so now the gradient, okay, so let's first, the gradient, I'm just going to use another color, the gradient when t equals 0, I just put it in there. So I'm going to get 0 plus 1 to e to 0 plus 2. And that's 1. And that is going to be 2 e to the power of 0 plus 2. And that's going to be 1. And that's going to be 2 plus 2. And that's just going to be 4. Now, so therefore, that's the gradient of the tangent. So therefore, gradient of normal, change it around, so it's a quarter, and change the sign. Okay, there's my point, there's my gradient. Let's find that normal. So we can just write here, at 0 and 1, the equation of the normal, and that is going to be now that point and that. So it's y minus, remember this is x, y, so y minus 1 is equal to negative a quarter x minus 0. So y is equal to negative a quarter x plus 1. But they want it in the other format, so I put it over 1, put it over, so I multiplied 4, so I get 4y equals negative x plus 4. And if I really put it in that, bring everything to this side, so x plus 4y minus 4 is equal to 0. And that is the equation of the normal.